I'm going to talk a little bit about a system called Sovrin, which is built on top of the code base of Hyperledger Indy that's hosted here in Hyperledger. Sovrin is a system that does digital identity. And this is a classic cartoon about digital identity, and that on the internet no one knows that you're a dog. Digital identity is a really interesting construct because when we talk about identity in the real world, we often talk about the idea of who someone is and how do you know. What do you know about someone that tells you that they are the real, authentic person that has interacted with you in the past? So here's a few correlatable attributes about me. And in this slide deck, I have a couple of links to places where you'll also see this same biometric, this same picture, to verify that these attributes really are mine and this is who I am. But when you start talking about people that you've only met online, people that you've only interacted with at a distance, what does it mean that they have continuity? What does it mean that they present themselves the same way? What does it mean that they have an identity? How do you match what that person is with what you know about that person? And obviously, people change over time. You know, these attributes weren't true about me some years ago. And of course, the things that I'm working on will change over time as well. So when we talk about Sovrin, we're talking about building a global platform that can accomplish digital identity, meaning that we can create webs of trust, and we can walk those webs of trust to discover things that we have confidence in. We can exchange signed and verifiable information, which sounds a lot like what blockchains do, doesn't it? You know, we have cryptographic keys, and we're storing state, and we're transforming state. But it turns out that the identity problem, although it has a lot in common with what we do in a blockchain, has a lot of insidious differences with what we typically do when we talk about blockchain. And Hyperledger Indy and Sovrin as an instance that's deployed globally of Hyperledger Indy deals primarily with those sorts of things. This is the basic stack model that we use for Sovrin and that the Hyperledger Indy implements. And there's some interesting things about what happens in this stack. We have the configuration ledger and the pool ledger that deal with kind of the mechanics of a blockchain, but we also have a domain ledger that deals with the sorts of information that you need to do in order to exchange identity information. But you don't want to put everything on the blockchain, because the blockchain is just used to publish things globally. And when it comes to identity, identity is not about who I am globally. It's about who I present myself to be in the relationship at hand. Right? You're not the same person with your family that you are with your business colleagues, that you are with your political associations, that you are in other interactions. And it's not that you're trying to be duplicitous. It's that not all of the attributes that you have are relevant in every place that you could present them. And so we selectively disclose things in order to facilitate the interactions that we need to accomplish. This is the essence of how we control who we are and how we have agency in how we choose to behave with the people we interact with in person and in the analog world all along. But when we start talking about translating these concepts to digital identity in the digital world, a lot of those constructs break down because we're using techniques that don't match the kinds of approaches that we use in the real world. So when we talk about the second layer of identity, we're talking about how do I have strong authentication, or how do I know that you are the same unit of context that I dealt with last time, and how that you are trying to present the same unit of context back to me this time. How this is typically accomplished in a website is a username and a password. But that identity doesn't exist in the user's domain. It only exists on the server that stores the secret that's being proven by the user. Right? And so the ability to exchange these correlatable pieces of information across parties is what we call verifiable credentials. Basically, we take signed pieces of information from an issuer, we give them to some holder of those credentials, and then that holder of the credential can selectively disclose or present the information out of those credentials to any verifier that they want to prove that information to. And there's a trust relationship between the issuer and the verifier, where the issuer has some reputation or some establishment of being credible in a way that the verifier can use. Right? The verifier might not actually know the issuer. Do you know someone personally at your driver's license division? But nevertheless, we trust the driver's licenses that we get from that relationship all the time. So this basic layer of trust is formed by being able to exchange signed information not on the blockchain, but being able to validate things based on what is anchored to the blockchain. So the blockchain isn't performing all the transactions. It's not acting as the system of record or as a source of truth. It's acting as a root of trust. So I don't have to have interoperability with every system of every issuer. All I need to be able to do is validate the credentials based on the protocol that's established in Hyperledger Indy. So here's some of the code base that we use in order to do this. We've been working on the Hyperledger Ursa library, which I hope if any of you are working with cryptographers or have cryptographic teams that are involved in blockchain at all, the group that's working on Ursa is a really great group, and there's a lot of interesting things going on there. We've been thinking about sponsoring perhaps a shared wallet project. So if shared crypto wallets as clients to blockchains is something that's interesting to you, please come talk to me about that. And then, of course, the things in green and blue are the code base that's currently hosted under Hyperledger Indy and the tools that we use in order to accomplish the platform of Sovrin. And there's a couple of pieces that are very particular to the public governance of the Sovrin network that we maintain inside of the Sovrin Foundation GitHub repository. All of it under the Apache 2 license. We're a nonprofit foundation that supports making a global public utility for identity that everyone can use. There's a lot of new stuff that's going on too. So if you're interested in getting involved, one of the things that's really great about Hyperledger is we have lots of people working on lots of different things. And we get along, and we get lots of interesting things done. So please plug yourself into what's going on in Indy, and we would love to have you. There's often a lot of confusion about what Sovrin is relative to what Hyperledger Indy is. This diagram may not make it actually clearer, but at least it explains what's going on. You'll notice we have a lot of different vendors that are contributing to the open source ecosystem. And they contribute in terms of building things for the code, and that's the thing that you see a lot of inside of the Hyperledger community, because we're primarily focused on the technology for the code. But Sovrin is also working to accomplish the governance of a system that can work at scale and can stay decentralized over time. And so there is an independent Sovrin community that's doing a lot of things around that governance, around deploying nodes and around managing and running a global blockchain that can accomplish being a root of trust, that doesn't depend on the DNS system, that doesn't depend on other external roots of trust, not because those sources of truth or sources of trust aren't helpful, but because they're so focused on what we would call issuing credentials that they can't neutrally manage this root of trust that we need in order to accomplish cross-domain or cross-silo identity the way we need it for individual people to be able to control or manage their relationships. So the Sovrin community facilitates and sponsors that effort, and I work for the Sovrin Foundation as CTO, and I do a lot of things to help companies that are trying to use Sovrin and are trying to use the Hyperledger Indy code base. So what I tell everybody who needs to learn the system is use my time. We love to help people get it started and get involved in the community. And if you want to get more of my time, then give me more of yours. Because we are an open source community, so just like any open source project, you can't just complain about something without having some work to do to fix it. Which brings us to this idea of decentralization, and really the purpose of what the Sovrin Foundation is for is, even if you have a system that can be strongly specified in terms of its rules, just like you change over time in terms of the attributes you have, the needs we have for any decentralized platform evolve and change over time. And one of the core strengths of the Sovrin platform is that it does have active governance in order to help it accomplish this purpose and help make sure that everyone has representation inside of that system to make sure that the guarantees of trust are preserved over time. When we talk about a blockchain, we're really talking about creating cryptographic keys and then collectively assigning some unit of meaning to all of those keys such that we have diffuse trust or trust in the collective of all those keys in a way that we couldn't have trust in any one of those individual keys. And that means that all of the units or all the capabilities that are provided through possession of cryptographic secrets can all establish the trust and integrity of data as that data changes and evolves. So when we talk about a public permissioned chain for Sovrin, what we're talking about is we have strongly authenticated nodes where we know who they are because they're permissioned. They have to use their permissions to become a steward or a trustee or some entity of governance on the chain itself. And that assurance provides us continuity that can be verified by anyone, because anyone can get a copy of the chain and anyone can submit the transactions according to the rules of the blockchain. And because anyone can create their own entities and own their own entities on the chain over time, and anyone can audit and validate that the permissioned entities are acting correctly, you don't have to rely on those permissions for the day-to-day operation of the chain, and you don't have to rely on those permissions in order to know that the identity is yours and that you own and control it. What you're relying on the permissions to do is to make it so that no one can betray the rules of the network and that it can run really cheaply and efficiently. Because instead of having to use proof of work and do things to accomplish global scale through brute force, we can instead leverage the permissioning system of the network to make sure it's fully BFT to protect and secure your keys and to make it so that it can operate at a higher scale even though we're operating in a fully public mode. Think of it as accelerating past proof of stake and proof of authority if you'd like. But this also means that there's some entity that we need in order to establish that those rules have continuity. Because if it was just someone like me that declared that this was so, how could you trust that it wouldn't change? How could you trust that I wouldn't change my mind because I wanted to move on to a different project or a different idea? And to do this, the Indy community doesn't directly control the code that exists on the Sovrin network. Instead, we have a technical governance board that approves and manages the requirements that go into the community, meaning they can ask us for stuff, and we can agree or not to agree as an open source community. But they can also approve or disapprove of the things that we release and choose not to deploy them or not to approve them and submit them as recommendations to the other branches of governance inside of Sovrin. We also have a board of trustees that represents the users' interests and the user advocacy that's necessary to make sure that their interests are preserved over time. And then we have lots of businesses and organizations that run the nodes on the network that are the permissioned entities that are the validator nodes. And all of these parties have decision-making power inside of the system so that they can act as checks and balances on one another and preserve the decentralization of what goes on. So we talk a little bit about the idea that we have trustees all over the world. We have technical governance members all over the world for the technical governance board. And we also have validator nodes all over the world. And I hope that some of you are noticing that your geography is underrepresented. And I hope you will also use that as an invitation to come talk to me about what you could do to maybe get involved in making the network more robust and helping enhance the concept of diffuse trust inside of Sovrin. So when we talked about our diagram up front, we really glossed over very, very quickly this idea of a connection. Agents are something that work on your behalf. Think of a real estate agent. Think of any sort of agent that exists inside of kind of your normal human interaction. We are clearly trying to imply that the software that manages your keys and helps you handle your digital interactions has a responsibility to answer to you and only to you. And when I say you, that could be a thing, that could be an organization, that could be a person, that could be a decentralized concept, like a public blockchain or a private permission blockchain. The idea here is that you have lots of API interactions that you can now have happen over the pairwise mutual keys that you have in any individual context, and that you can then selectively disclose information across that channel. So if we jump back, when an issuer issues a credential, they have a public reputation, so they create a credential definition on the ledger. And then they start issuing credentials. They're not writing any data to the blockchain to do that. They're simply asking in your pairwise relationship, so I have public keys for my public reputation, but then we form private keys to have a private interaction. And then you can blind a secret to say that this credential is uniquely issued to you and only you. And I can issue you a credential that's, instead of it being bound to the DID relationship that we have for authentication, it's instead bound to your wallet using your mechanism of choice. That way you can selectively associate all the attributes that you have against any pairwise relationship that you happen to have across the network and across the system. And in this way, we create a system where you can reduce the amount of correlatable information that you share. Instead of having to have a single DID, which is a decentralized identifier, that you're using for all your relationships, instead you have unique decentralized identifiers that invoke the specific relationship that you're trying to communicate about. And that concept is what we call a verifiable credential. Verifiable credentials is a specification that's being incubated at the W3C. We're getting close to the first candidate recommendation, although that candidate recommendation only deals with the data model and the data model alone. And there's some things that that candidate recommendation does that are actually really harmful and dangerous to the idea of information exchange that preserves privacy. And one thing that we advocate for and we do a lot of work on inside of the Sovrin deployment of Hyperledger Indy and inside of the Hyperledger Indy code base is we work really hard to make sure that we can preserve privacy as information gets exchanged. And so instead of just using signed data and exchanging that signed data everywhere, we use a technique called zero-knowledge proofs. It's also often called an anonymous credential, so that the issuer issues a credential to the holder, and then instead of proving something directly by disclosing the signed data, which would be transferable to any party who could get a copy of it, they instead prove things in zero knowledge, so that the information that's shared is not transferable to other parties, and that the identity holder can retain their control for disclosing the information over time. So that was a real fire hose of a lot of little bits of information. The Hyperledger community is really friendly and open, and I hope that some of you can kind of see that there's a lot going on here, and there's a lot of things to talk about. But I would really like to drive the rest of the time that we have here together before the next presenter comes in based on what your questions are and what you would like to talk about in terms of what Hyperledger Indy is up to. and what we're hoping to do next and what we've done so far. So I'll take questions.
I just wonder what's your take on managing basically the credentials. Like basically you can either manage them by yourself in your wallet, but then you risk when you lose them and you lose your identity, or you can outsource the responsibility to some other party, right? But then somebody else actually owns your identity. It's not self-sovereign anymore. So there's I know I heard of the concept of like shared keys and a master key, like something like that.
So we just took all of the idea of credentials or information sharing, and we said that that's all about key management, because now we're using cryptography for all information exchange. We just took all the idea of relationships and individual contexts, and we said you're not going to have one identity and one cryptographic key. You're going to have one per context and per relationship. Well, key management is hard enough. We just made key management that much harder, didn't we? Because now we put key management in the middle of absolutely every layer of the system. That's part of why the brain diagram of your agent working as your brain has so many weird colored dots in it, because the idea is you're going to have a lot of cryptographic keys. Now, there's some interesting insights, though, when you start approaching it as an identity problem instead of strictly a blockchain problem. The first is that because keys are now about context, we're using key management as a unit of relationship, which it turns out our human brains are pretty good at dealing with relationships and who we know and who we interact with, and they're really bad at dealing with cryptographic problems and cryptographic keys. So instead of thinking about your cryptographic keys as, I have a key and I need to rotate it and I have to not forget it, you can start thinking about your keys as a contact list. And the software can start to automate a lot of the details around how keys work and how you interact with those keys. The other thing that's really interesting about this model is now we have both the idea that you have keys as the controlling agent, which is like what you would think of when you think of your keys for Bitcoin or Ethereum, but we also have this idea of an identity agent that's acting on your behalf and you're delegating control to it. And we have the idea of all the people who are issuing your credentials and they're interacting with, and they all have keys too. Now think of this, it's an identity platform. Identity is about the relationships that you have, and your relationships want to help you continue to be you because they find value in interacting with you. So we have multiple layers of the system that help us build what we call decentralized key management for managing and recovering how to recover your keys. And there's no magic or secret sauce to that. It's the same things we've talked about for a long time in terms of Shamir secret sharing, in terms of escrowing, in terms of things like zero-knowledge proofs in order to be able to prove possession of recovery secrets and hints. And we have a public blockchain that can serve as a public oracle. But when we have these multiple layers that we have trust relationships with, we can use one layer to help recover all of the others. And that's really what we talk about when we start talking about decentralized key management.
So that recovery includes rekeying and
If it didn't include the rekeying, you wouldn't be you anymore, right?
yeah. Can you just repeat the question so we can all hear it? It's hard to hear.
Okay, the question was around key management, that we've essentially turned all these problems into a key management problem. And the other piece that was asked was, I've heard about things like master secrets and pairwise secrets. The idea is we have keys that we use to talk to one another. We usually call those pairwise decentralized identifiers. And decentralized identifiers, the idea is that in some decentralized system, you've registered that you own a particular identifier. And there's a key associated with that identifier. So the idea is that you have keys for your relationships, you have keys for being an issuer, and then you have keys associated with the credentials that you share with zero-knowledge proofs. And so there's a lot of different kinds of information that go in a wallet. I think that's the end of our time. So thank you very much, everyone. And you can find me in the hallway track for whatever you'd like.